Okay. So queues and stacks are ways that we can interact with a linked list in a way that is reasonable. Queues and stacks operate kind of like, again, kind of like an array. They're not technically arrays. They are kind of like arrays.
Okay.
Somehow I think you're saying that for me.
No, because I now have a Harry who lives in my head and says they're not arrays, Ava. I go, kind of like.
It's funny.
So they're kind of like arrays, but they're not.
Yeah, they're not, because they're not stored in memory the same way that an array is.
So, and they don't really function exactly like an array. They operate kind of like an array.
I think you need a t-shirt. I think you need a t-shirt at this point.
So
Wow.
a queue is first in, first out. So the first thing that goes into our queue is the first thing that comes out of the queue. So here I am adding numbers to a queue. And if we were going to go through them, they would go 1, 2, 3, 4. So that is how we operate with a stack, with a queue. With a stack, it's kind of like pancakes. First in, last out. So we do 1, 2.
You mean last in, first out?
Yes, last in, first out.
Yeah, you can't really eat the one on the bottom with all the other ones
Or-
sitting on the top.
Or first in, last out. Last in, first out. I go with FIFO and philo. So the last thing that we put in here, our top pancake, we eat it this way. So that is the difference between a stack and a queue. Does that much make sense?
Yep.
Cool. So, Carmen, is that good to go?
Yep. It should
Yvette,
be.
does that make sense?
I just joined like a minute ago when you mentioned the pancake.
Hey, June, I've not met you before. Nice to meet you.
Yeah, I just add him.
Got invited from Yvette.
Okay, so one more time.
I'm sorry.
No, I'm laughing because I feel like Doc and Joanne can quote me now. So a queue and a stack is kind of like an array. It's not an array. It operates kind of like an array. You put things in it, it's in an order. They're not stored in memory, but it's a way that we can interact with a linked list. And it is a thing that you will need to use during your code signal tests. So a queue is first in, first out, like at the grocery store or in traffic. So the way that you stand in line, we are all people with names, 1, 2, 3, 4, 5. The first person in line goes first, and on, and on, and on. A stack is like pancakes. The first one at the bottom is the last one you eat. First in, last out, or last in, first out, depending on what acronym makes you happiest. So we go again, and the last one is the first one that we work with. Okay? Yvette's giving me a frowny face.
She must eat her pancakes from the bottom up.
Yeah, so with a stack, so with a queue, you can actually use both of those acronyms. With a stack, you cannot. You can only use one. So because you're stacking one on top of the other, it must be last in, first out.
Okay.
Like plates. I mean, you're not really going to pull the one from the bottom when you could just take the one from the top.
Unless
Right.
you're short.
It will never be first in, what's it called? First in, first out.
Yep. We first in, last out. The first one that's in is the last one that's out. Or the last one that's in is the first one is out.
Yep. Last in, first out, first in, last out.
Yeah, no, that second thing is not a thing. So it's either
It's either LIFO or FIFO.
yeah, it's either first in, first out, or last in, first out. Those are the two acronyms.
They're Python.
Ava's just adding some more. She just is like doing the Ava thing on the whole deal.
Yes.
So, question.
Yes.
So last in, first out is stack, and
Yes.
Q is the first in, first out, right?
Yep.
Right. But Q is actually how British people talk about a line. They won't tell you like, get in line and get in the queue, basically.
Well,
So think
that's
about it like a
because
line.
British people actually get in like a massive horde at the grocery store, and then they go to like the individual cash registers, whereas Americans stand in line at a particular cash register.
Mm.
So they actually do queue properly. Americans just are strange. British
I'm
people
always in the slowest line. Always.
and therefore Doc would benefit from queuing. Okay, so now all we're going to do today, as I said before, is we're going to go through a queue, a stack, and then work on our and then we're going to go to doubly linked lists.
Okay.
But because we have a linked list in, we're going to use our queue. We need to import our linked list. That's the first thing we have to do.
Okay, I don't know how to do that. What do I do? I
So,
just
on line 19,
Mhm.
from, okay, well, actually, no, on my line 19, on your line 15, 14.
I was gonna say she needs to do it up higher.
So we are going to, from singly linked list dot singly linked list import. You're going to put a space before import. What do you think we're importing?
I don't know. I've never done this.
Linked list.
Linked list.
That's right.
Oh.
So we're importing the class from the file.
I just say linked list.
Perfect, June.
I was just guessing.
I encourage guessing. I encourage wild guesses.
I didn't.
So-
I didn't know they have a library for linked list like separately.
They do not. We have created a linked list yesterday.
Oh, that's why. Okay.
So now we have our linked list that we're working from today. So the first thing we're going to do is we're going to initialize our queue. We're going to have a size of 0, which is what we've already got there. And now we're going to initialize our storage.
There's
So
something
what do I
I
do? Just uncomment this?
Yes, Doc?
There's something unhappy
Oops.
on line 16. Holy smokes.
Oh, it's because did you put your singly linked list in the queue? Where's that? Why is it unhappy? Oh, it's happy now.
Okay.
It's
Maybe
probably
just she
some-
didn't save it or something. Who knows?
Probably.
There was a squiggly under the from.
So self.storage equals our linked list. Invoked. You have to invoke it. Okay. So our storage is everything that's inside of the list. Our size is the size of our queue. So our size is never going to exceed the total amount of the total size of our storage, essentially. Remember how yesterday, no wait, that was this morning. We'll get there. Our storage, our linked list has a size. Our size is never going, the size of our queue is never going to be any longer than our linked list, is essentially what that means.
Okay. So just leave it this way?
Yep.
Okay.
So our next method is our length. How would we determine the length of our queue? We have two variables. What tells us the length of our queue?
A self and value
Size.
Very good, Yvette.
size.
So we're going to return.
So I take this pass out.
Self dot excellent. So we're returning the size. That is the length. That is going to be the length of our queue.
Like this.
Nope. Take out that colon. That's it. All done.
Okay.
All right. Now, to enqueue something means to add it to the list. Now, yesterday, we created two functions for adding things. Excellent. So,
Come and be like, I'm getting there.
so
I'm getting
first thing that
there.
we need to do is we have to increase the size and add at the tail.
So I'm gonna put increase size.
So how do we increase the size, Carmen?
So let's see, how would I increase the size on this?
The food.
I would just add to, we can't do that.
Yes, you can. Self.
Okay. No.
We have
Right.
two. Remember, we have two
Self dot size, right?
things.
Okay.
Now we're going to
let's do
increase it by 1
one.
plus equals because we're updating.
Okay.
Very good.
And then 1.
Excellent. And you were correct. We're going to add at the tail. So now storage is where we have our links list.
Okay.
So on line 29,
Self dot storage.
and do you remember what add to tail was? Self.storage dot
Next.
what did we call our
Oh.
function add to tail? Look over at your singly linked list.
Yeah.
Node. New node.
Was it new node?
No, look at the singly linked list. We made a method. What was the method called? Lines.
Add to tail.
Yeah, very good, June.
Hold it. Okay.
Add to tail.
So do I
Dot.
just dot?
Add to. See, we've got it. It's even right there. Add to tail. And what do we pass into our function?
We need to pass in what we're adding. So that would be value.
Perfect. Wonderful. So now to dequeue is how we remove things from the front of the list. Good.
So do we do it the same way? Like instead of self.size plus equals 1, we could do like -1?
Minus equals 1.
Minus
Yes.
equals 1. Okay.
Minus equals 1.
How do I do that? I'm still trying to put that plus in there.
And our
Dot.
remove head.
Why did I put tail?
Very good. That's it. That's a queue.
Let me look at this.
We don't have the value there. We don't have a value being passed in.
Oh, yeah, we're taking away. We don't need anything.
Right. So make sure that when you're creating your functions in your code signal, make sure you look at what you're actually working with. So your parameter would have told you that we don't have a value. We just have self. Self tells us what we have access to.
Okay.
So does the queue make sense? Does anyone have questions about self? Why is your... Hover over that red line, please.
Oh. Mm-hmm.
So I have a question for the self.
Mhm.
So is it mandatory to put self everything?
Because this is a class, yes.
Also, so from JavaScript, I think we
you
put
would have used this.
but we don't put this every single function or method.
Yeah, this is not the same thing as self.
No,
Yeah, that's why I'm asking, like, why we doing it? Yeah, why we're using self in every single function?
Self refers to the head, right?
Self
head
refers to the class of... Self refers to itself.
So it's referring to class Q.
Yes. The size of class Q, self size equals 0. If we were passing in another variable, we could do self.size equals size. Self.storage equals storage. In this case, self.storage equals linked list.
So anything that we creating new variable or something
No,
like
anything in the initializer.
uh-huh.
That if we're creating a variable in the initializer, we're assigning it self.
Okay.
If you create a variable somewhere else, go ahead and look at show linked list, Carmen.
Okay.
Okay. Go to the bottom where we have remove tail. So we have a pointer here. So this is not a part of the class. This is just a variable. So you don't have to have self.pointer. We don't have a variable pointer within the initializer.
So that
here,
pointer is only live inside of the remove tail, right?
yes, and the same thing with new node. This new node only lives inside of add to head.
Okay, and everything that you use self.head, self.tail, or self.head.next is live inside of the init function.
Yes.
Okay. Okay, now I get it. Okay.
Yeah, so I would put it this way, that self is a reference to the current class within a class, and as opposed to this, which refers to an object instance.
Okay.
Does that make sense?
Yeah.
So in this instance for the queue, self refers to the queue or the linked list?
It refers to the queue.
Correct.
Self.storage refers to the linked list.
Okay.
Whoops. So self.size refer to the queue.
Yes.
Okay.
Self.storage is our linked list because we told it to.
Yeah,
So
but it's still, I mean, the self
But
part of
it's-
that is referring to the class Q.
Yes.
Yeah,
The self refers to the queue. The storage is the linked list.
right.
Okay. Yeah, honestly, I think Python is more readable
Mm-hmm.
Oh, 100%.
compared to
Definitely.
JavaScript.
I don't know why it's giving you a fuzzy on that.
It's something to do with my ESLint or something. Like I don't really know what, or my PyLint. Like I don't know what it's doing. I don't know how to use it. I never
If-
used the Python.
If you actually run it, it will work. It's just for some reason on some things the PyLinter will yell at you, but if you actually run it, it works. Because it's
They
not-
don't have can't find the module.
Oh, that's
Did
because you're in a
Did we
different.
export it?
So
We
because
can-
you're in a different directory.
I think Yvette said did she export it?
To do.
You don't need to export it.
Oh, in Python we don't need to export it.
No.
Nice.
Wow, that's pretty awesome.
Nice. Yeah.
This is what we did in the morning. I just sent it in the Zoom chat.
Oh, you did that. Okay. Go ahead and use that one that Joanne just sent to everyone in the Zoom chat and paste that there.
It's a pathing issue. I really stink at
It's-
doing paths.
Oh,
it's
wait,
in
the Zoom chat.
Zoom chat.
Yeah, Zoom chat.
Yeah, that is using the import sys.
Yeah, what that's doing is adding it to runtime.
So where do I put this?
We're on line 16
Line 16.
in place of what you currently have. So just delete that and paste this over top.
Okay.
And-
It's
Nice.
on now. Ah, yeah. This computer.
Oh,
Eh.
delete line 18.
Yep, there we go.
Actually, is it?
Oh, you still need that.
No, you still need that. Never mind. I don't know. It's just mad at you.
Yeah, I had these problems a lot.
Do a quick edge case and do if self.size equals 0 return. Line 34.
Line 34. I'm gonna come down. So if self.size
Equals 0. Double equals 0 colon. Next line. Return. Just check for your edge case. We have finished our queue.
Mhm.
Well done. We have an import issue. We're going to pretend like we don't.
Okay.
And we're going to move on to stacks.
Doc said she had an idea.
Oh yeah. Let me grab that real quick. I got off task. Sorry.
So in the meantime, while Doc fixes that, we're also going to import our linked list in stacks. Joshua Williams. We got all the brains in here tonight.
Let me try this import again and see if it works for the other one. Sorry, I don't want to do the shortcuts right now.
So Carmen, do you think you can set up the self.storage?
I'm just gonna uncomment it and let's see. Let me remember. How did we store last time? Oh yeah. Let me just look at the queue. Just kidding.
Nope, nope, no looking. No,
It's too
you
late. I
broke
saw
it. Close your eyes.
It's too late.
I saw it. Sorry.
All right, now do the length without looking.
Oh, I'm not gonna be able to do this without looking. I have the memory of a goldfish.
Nope.
Okay.
Sure, you can. You can do it.
Yeah.
Who believes in me?
Do it.
Okay, let's see.
Everybody, we all believe in you.
Okay, I know something about this. All right, so the length of it, we had to do. No, I can't remember.
So look at your initializer. What do we have in there?
a self. No,
Okay.
wait. Yeah, self.
And what are our two? So you got a 50-50 chance.
You can actually get it two ways.
Shh, don't confuse her.
Yeah, don't confuse me. Don't do that. Oh my gosh.
Okay, and we got to do something with self.size. No.
Okay.
Don't confuse. Don't complicate. No. No. You got to
Okay.
return it.
I was just fixing to
Yep.
say it was in the front.
No, no,
Right here?
return self. No, on line 22. There you go. That was it.
Really?
Yes.
Isn't that annoyingly simple?
Yeah, I think I was trying to overcomplicate things.
I think you could have did it like self.storage.size or length. I think that there might be like a length property on linked lists. This
Yes,
one.
but this is for the purposes of something else. You have to use the size.
Yeah, I think it's the test.
Yes, for the purposes of the test, it wants the size. It does not want the length of the linked list. It wants the length of itself. So very good.
I like that. That wasn't right.
Mm-mm. Yvette, what was it?
No, it's not right.
Ah, there we go. No, that's correct. Self.storage dot go and look at your singly linked list. We're going to add to the head.
Yeah, we're gonna add
Head,
to the
yeah.
head. Why
So-
do I keep trying to type that then? Duh, it's self.storage.head.
Dot add
It,
to
it just
Oh, I know what we're doing now.
Underscore
Oh my gosh.
and this.
Yeah, we're going
Yeah.
add to head.
there you
Yeah.
go. And then what do we do
This is the
inside of
part I'm
that?
trying to
We have
do.
to invoke it.
Yeah.
'Cause it's a method. And then what do we pass inside of it in order to add something?
The value.
Right. So remember, when you're adding, we have the value. Now,
Mhm.
what do we need to do? One thing before. We're going to add
Hmm.
something to our stack. Our stack currently has a size of 0, but now it's got
0.
one thing in it. So
Self dot size.
but you got to go above the self dot.
I mean, like, yeah.
So we need to what? To keep track of the
Self
size?
Dot size plus equal. I mean,
very good.
like, you added.
Exactly, Yvette. Good
Yeah.
work.
Awesome
Okay.
sauce.
Awesome, so.
Oh,
So in other words, in this, it's push is like adding, and then pop is removing.
That's right.
Oh, okay.
All right, Carmen, you can do it.
okay. Here we go.
So you need an if self.size.
Hmm.
If
I
self.size
can't do it.
equals 0.
Oh, it goes on the same line.
Double equals 0. Colon. So remember in Python, you have to do the colon. And then pop that in.
Return none, or can I return null?
You can just return.
Okay.
And it needs to go in one tab.
That's right.
All right. Now we can do that lovely remove from tail function.
Okay. So
Now go back. No, go back. Backspace. There you go.
and then we're going to remove. So we're going to minus equals 1. And then
And June, if you want to follow along, you can. The link for the repo is in, what was it, 2 mornings ago, I believe, right, Ava?
Yeah, I got it.
Oh, okay.
Do you need a value when you're removing something?
no, that's right. I keep wanting to put the value in there, but there's nothing because we're removing.
Right. So make sure, again, this is for your code signals. Always make sure you look at your parameters to see what you're working with.
Okay.
All right. There we go. Stack and queue, but our import values.
Yeah,
our
go back to,
imports.
yeah, go back up to your import.
Mhm.
Okay, so do import OS comma sys on line 13.
Yep. Import,
Space, comma.
comma.
Yeah, that should do it.
Oh.
It didn't.
Here, I've
Oh.
got another one.
You have to put back in the, okay, so this is the name, you have to put back in
Should
the dot
we-
notation. You have to go down to line 15 and put back in the dot notation that Ava gave you.
Singly linked list dot singly linked list.
Yes, ma'am.
Whoops.
If that doesn't work, I got another sys path that you can use.
Oh, ye of little faith. This is gonna work.
There we go.
Yay!
No, it doesn't.
Okay,
Can
put your
we
cursor-
make a space between
your-
line 15 and 16?
Yes, we should
Mhm.
make a space between line 15 and
Yeah.
16. It
put your
will
cursor over the from.
Oh.
that fixed. No, it didn't.
No, well, unable to import singly linked list. Okay,
Can
there's no spelling errors here, right?
No, Joshua
guys,
sent
Can-
a
so correct me if I'm wrong. Can we do something like imports the linked list from singling list? Can we do that? Or we
No,
have
because
to.
it's in a different directory. So
Carmen,
singly linked
look at the
list is-
chat. Look at the Zoom chat and try what Joshua just sent.
Hello, baby. Did you wake up? Oh, you're cute. Little
Is
cat
that the
cat.
kitty again? Too bad. My daughter was
Kitty,
just in
kitty,
here. She
There he
looks
is.
what is the difference,
Victoria.
Josh?
Hi.
I need to pull that over to my other
What is this thing trying to tell me?
screen so I can see it.
Ignore.
Wait a minute.
Unusual.
Ignore. I didn't ask this thing to do anything.
Get. There is a
Oh,
strange
okay.
thing there.
Hmm.
Can you do
Really?
the Alt Z? So it's will.
That should have been a parenthesis. No, a space. That should have been an enter. Where you have those scary things, that should have been a new line.
So right here.
No, right. Yep, and there's a new from singly linked list. Look over to the left of my little pink arrow.
Posted it on the thread on Slack if you want to grab it from there too. Like
Yeah.
it's on one of
There you
these-
go. And then a new line there as well.
And what are these these question marks?
There you go.
Okay.
That was the new line marker.
Oh, I don't know. That's what I'm saying. Like, this is not set up properly for Python, so we're just gonna have to ignore it because it's doing something that I don't even know what.
All right. Well, we'll just
So-
take it on faith that my code works then.
Yeah, I would say run that puppy and see if it works. Oh wait, wait, go back up. It's not add another parentheses all the way out on the end of line 14.
Okay.
Add one more.
Parenthesis, not curly bracket. I think it's got an. It looks like it's got enough parentheses.
Oh, it's not,
Yeah.
but it does. The first one is red there. So there's missing something somewhere.
No, it's orange, purple, blue, blue, purple, orange.
Yeah. The
There's
parentheses
an
are
orange
right.
thing in there? Oh,
Yeah.
okay.
Wait, can you put comma after line 13 OS or something like that? Because it
Yeah,
might.
that's not.
Oh.
No, wait a minute.
Now look, now it moved to under the comma.
So I think it's something like, cause it's going to read like OS and SYS that path, you know.
My
Even though
input
it's-
kind of reading
Yeah,
it
in order to, what this is doing is appending. So when Python import looks for imports, it starts with, what is the first thing that it starts with? Somebody help me out here.
The directory that the file is
The
in.
directory that you're in, and if it doesn't find it there, then it goes to the standard library. And if it doesn't find it in the standard library, then it looks in your system path. So this is literally appending at runtime your system path to give it the location of this file. That's what it's supposed to be doing. And there should be, according to the documentation that I'm looking at, line 15 should include the dot notation.
Okay. So okay.
Wait.
Alrighty.
Let me, I'm gonna double check myself here for a second. Yeah, it should have the dot notation. And you're importing the thing.
I
Yeah,
don't know.
so this is literally the code that's in the documentation that I'm looking at. It's a little bit different than
I'll try it.
you see, I mean, you have to edit it, right? Because it's not, it doesn't, it's not taking into account your, like pack A is nothing that you have.
So
right.
it'll be
So singly linked list dot singly linked list.
Right.
Yeah.
And then I don't know what SA2 should be. Import linked list.
Yeah, import linked list.
Yeah.
Yeah.
And then you have to go up to line 14.
And see, if it was just recognizing linked list from there, so it should work, even though it's still giving you the squiggly under from. Because if it's pulling it up when you start typing it out, that means that it's recognizing it already.
Mm-hmm.
Okay.
So it should be fine. I mean, I don't really know what's wrong with it.
This is a debug session for perhaps a breakout room.
Yeah, something.
Yeah, so I would
learned.
love to see this. Is there something here that's like executable?
Mine is.
It
But-
should I mean, I don't see any reason why it wouldn't execute.
It should execute, but I don't know what's up with the
Yeah, that's
Import.
something weird.
So did that keep it from executing, or did you try?
Mm-mm. No, it
Yeah.
ran. It ran. It's
It-
just giving back those same little issues.
Okay. So yeah, so if that's
So,
just
that should
a
be fine.
problem and not a what do you call it, a bug, then
Mhm.
Joanne was right. It'll work. It's your linter's not happy for some reason.
Yeah, it should be fine.
All right. Let us move on to the doubly linked list and beer.
Double linked list.
Do I need to edit that part out too?
Nah.
Okay, so
I drink on my own time. I don't drink on Lambda's time. Usually. All right, so we can get rid of our singly linked list, our queue, and our stack. Because we are only working on doubly linked list. So look at the top, Carmen, and close those 3 tabs.
okay, I can't see it because it's blocked by my Zoom thing. So now I know what you're talking about.
So now we're only going to work with our doubly linked list.
Okay.
So more drawing time with Ava. So we worked yesterday with a singly linked list that had a pointer, and that pointer was next.
Mm-hmm.
So our pointers pointed to next. Today we have a doubly linked list. Doubly linked list means how many pointers?
2.
Woo! Which now points back.
Okay.
Doubly linked list. Is everyone following so far?
Yep.
Okay. So if we look at our list node, because now we have a new, as yesterday we had a node, now we have a list node. Carmen, what do we have in our list node? We have 3 values.
Okay. Let's see. We have a previous a value and a next.
We have a previous, a
A
value.
self a value, a previous, a next.
That's right. We have a previous, a next, and a value. So those are the 3 things we have to be paying attention to. Yesterday, we had a node which had a next and a value. Now we have a previous and a next. Now let's look at our initializer for our doubly linked list. So what do we have in our initializer?
Self and a node.
Right, and our node is
Equal to none for some
Yes.
reason.
And our node is eventually going to be our passed in thing.
Okay.
So we have a head, a tail, and something slightly different.
A length.
Right. So where's the head?
Right here.
In the list.
Oh, in the list, it's the first node.
Good. And the tail?
Was the last.
And where does the previous pointer of head point?
The previous pointer to head points to the end of the list, right?
Points to none. Head
Does
dot
it?
previous points to none. Where does tail dot next point?
Tail dot next points to nothing, I guess.
That's right. So head dot previous is none. Tail dot next is none, right? Because we still have a beginning and an end of the list, even in a doubly linked list.
Mm-hmm.
Everyone clear on that?
Yep.
All right, cool. So first things first, we're going to add to the head. So first, very first thing we need to do. Very first thing we need to do.
What's in the parentheses there?
The value.
Right. So we need to create a new list node. So like yesterday, we had to do a new node.
Mm-hmm.
And then we had to instantiate a node and give it a value. We have to do the exact same thing here when we add.
So we're
Right where you are.
Mhm.
New node.
like this.
Sure. Equals. What are we calling our node this time? Scroll
I
up.
think we're just going to call it
Scroll up and look at the class.
doubly linked. No, list node. Oh, okay.
And then and then our next thing that we have to do is pass in the value. So do you remember that when we're adding, we have to create a new node? Okay. Excellent. So the next thing that we need to do
So when we're adding, we have to create a new node
Yes, anytime we add, we have to create a new node.
because there is no new node.
That's right. Because there is no new node. We have to create it ourselves.
Hold on one second. Flip baby, whatever you need, can you just call dada? Because I don't know what you want. Here, call your dad. Call your dad. Okay, sorry. My daughter keeps trying to write me notes. Okay.
So then the next thing we have to check for, how do we check? What's the first thing we should check for, guys?
We should check to see if it's empty, first of all.
Excellent. So if
Right here.
Mhm.
If new node, not new node, if the list node,
if self
self
dot
Head.
yes
self dot add
head
Head.
if self dot head is
oh, the word is
none. If self dot head is none, then what do we do?
just
You had to
return.
type all of We're adding. Yvette, you had to do this yesterday. What do we do?
We add a new node into the head.
That's right. So self
Yeah.
dot head, and then we make it no double equals is a comparison. A single equals is an assignment.
Mhm. So stuff that head is equal to the new node.
That's right.
Yeah.
And because there's only one, now what do we also have to do?
Since there's only one, we have to create the, we have to make the pointer.
No pointer. We have the head, and we need the
tail.
tail. Remember, I think I drew a picture of a mouse at some point.
Yes.
So we have a head
The
and a
stuff that head
tail.
is equal to- So we need to do the same thing for the tail.
Well, that looks more like something else, but I'm not going to say.
It's got ears.
What? I think it looks like a Mickey Mouse balloon.
Joanne just has a dirty mind.
Well, how do you know what I was talking about, Josh?
Oh, that's a good question. Exactly. Okay.
All right, so you understand that, Carmen.
Yes. So since the list node is brand new, it's the head.
Since the head has nothing in it, since our list is empty.
Okay.
Our
me
list
look
is
at it again.
empty. We have to put, when we put one thing into it, it is our head. It is both the beginning and the end, the alpha and omega.
Okay. All right.
Like,
All right.
there's like an edge case, right? Like,
Yes.
because like their self dot head could have the value of none. You know what I mean? So there could be a node there, like a list node there, but it itself have the value of none. So in that case, on line 31, it might be better to say if self dot length is equal to 0, right? Because that'll hold whether it's empty or not. That's like an edge case right there. Because if
super edge case.
Yeah, that could happen though. Like weirdly enough, that's something that you would test for whether the head itself has a value of none. Because if it does, then it's still a node there, but it just has the value of none.
So that on line number 31, that word is the same thing, same as the double equal sign?
It is somewhat, but
I'm gonna go with mostly.
Yeah, you have to use it in a different way than you do that.
You used is with none. You use double equals with other things.
Oh, okay.
We're not done yet, Carmen. We have only done one thing. You need to put past back in.
Okay.
I'm going to pop in here real quick and say quickly about is versus double equals. So they're like Ava said, they're mostly the same, but what distinguishes them is that the is operator says that both of the variables point to the same object, which means the same memory location. And the double equal sign checks if the values of the two variables are the same. So is same object, same memory location, double equals, the values of the variables are the same. So it's not referencing the object or the memory location. Does that make sense?
Yes. So that self.head is not pointing to any memory location, right? Line 31. That's what it means.
So it's not pointing, okay, so if both of the variables are pointing to the same object, that's when you would use is. So self.head and none would be pointing to the same object or the same memory location.
Yes. That totally makes sense.
So Ava, here again, you're not going to use a placeholder?
No, because I didn't bother when I wrote it, and I'm not trying to pass their tests.
Oh, okay.
Just make that equals 1 instead of plus equals 1, because this is the very first time that we're doing something, and you might as well make sure that it's not going to break.
Okay.
So now we have done the edge case. We have not completely added to the head. So now we're gonna do we have, perhaps there is a massive list that we're going to add to the head too. So go back 1 tab
Mhm.
and give me a new line.
Mhm.
And this is my favorite thing in the world. Self.head.previous.prev, P-R-E-V, equals new node. Self.head equals new node. Next line. Next line. No, what are you doing? No. New node. Next line. Self.head equals new node. Self.length plus equals 1. New line, Carmen.
Well, you didn't say new line that time.
You got it. I need you to start thinking ahead. You can do it. I believe in you.
Self.length plus equals new node. Why did I do that backwards?
1. Plus equals 1. All right, so yesterday what we had to worry about was our .next. Now we have a previous. So basically, the old head's previous pointer pointed to none, correct?
Mm-hmm.
So what did we do?
We flipped it to point to the next node.
We made it point to the new node.
Right.
Now, there's one thing I forgot to do.
Because you got to move the head.
Yep, line 37.
Mm-hmm.
No, yeah.
So just do
Yep,
this.
just another. New node dot next. Can I do that here? Yes, I can. Equals.
And dot next equals the previous node. No, that's
Self.head.
wrong.
So new node not dot next, as long as it's above or before the self dot head, then it's okay to do it that way, right?
Yep.
Okay, I'm about to bite my keyboard in half. We don't use camel case in Python. We use snake case. So
I have to start using snake case like it's like a must.
Yes, it is more Pythonic to use snake case. It is actually PEP 8 to use snake case.
yep. And
Okay.
convention across the world.
Yes.
So
I don't know why I thought it was more of an option, but okay.
it's
Well,
not.
Because
I'll use it.
because no one has told you yet.
Yeah, no, I mean nobody really has, so I've just been writing it, however.
I was
but
trying to
now-
be patient and wait, but it kept coming up.
All right. So
Okay.
there
Well,
we
we've
go.
got to use it now, but we'll use it next time.
Now, so we just added to the head. Now we're going to
Subtract from the head.
I was
There
gonna
we
say on that add to the head, you might want to put like an else after that if, and then tab everything under 36.
You do not have to have the else there.
It's gonna happen twice.
We can return after line 35.
Oh, just put return.
Just put return. I forgot that. My bad. Thanks, Joshua.
You mean tabbed in though, right? Like
Yes, tabbed in.
oh,
All right. There we go.
So remember, Carmen, with Python is very, very persnickety about spacing. All of Python's scope is spacing.
Yeah.
So whereas in JavaScript, you could type everything all over the planet as long as it was inside those stupid curly bracers. welcome to Python. We never have to worry about a matching curly bracer again.
Okay.
Or a missing semicolon.
I
No more
came
of
from
that.
I came also from PHP.
Oh wow.
I'm so
Semicolons.
sorry.
Semicolons. That's all I got to
So,
say.
so sorry about you.
So, removing from head. So the first thing we should probably check for is,
If it's empty.
that's right, we got to check, is the head even there?
Yeah, self.head. There's none. Can we just, I mean, is there something particular we need to do?
Just return it. Just return. We
Just-
stop the
okay, that's
function.
easy.
So returning stops the function.
All right.
Cool. Well done, Carmen. So next, and give it a space. Python likes spaces. So if you had PEP8 and everything was all squished together, it would yell at you.
Really?
Yes,
Okay.
PEP8 in PyCharm makes very certain that you are following its conventions.
I
And
think
it
I'm
gives
going to
you
download it tonight.
It's got a little bit of a learning curve, but it's fantastic. And I'm really mad that I have to use VS Code right now.
Sorry.
Like, I also really want to know how to turn off this thing.
What thing?
This
I
little
can't-
side scroll, what's it?
Oh.
That drives me crazy in my own environment.
Oh, wow. That's crazy.
All right, so we checked if the head's there. Then we returned it if it's empty. Next thing we're going to do
Is,
now this wants us to return the value of the removed node.
okay.
So
we do.
I need a variable, and then I want you to save the value of the node that we're going to remove.
Okay. I don't know why it's doing that. All right. So I promise I'll use snake case next time. Remove node.
That
It's
will, my ulcers are happy to hear it.
Oh, what should I put here? Just 0 for now? Or
Self.
no, it's going to be self dot.
We're removing the head. So self.head. We need the value of the head. There you go. Good job. So that is our value. Moving on.
Okay. Why did it do that? It said values and then it put a thing here. Yeah, I am kind of tired of VS Code now. Okay.
I like
So-
VS Code. One of the reasons that I like VS Code is because I can go down the terminal window and start a new Jupyter notebook. So I can code in this environment that you're looking at right now. I can do IPython in the terminal. I can start up a Jupyter notebook and it loads up in VS Code. Exactly. It's multifaceted. There is a linter that I use that's not the same one that you're using, and I should probably get that to you.
Yeah, that'd be awesome.
I love that the reason that Doc likes VS Code is because she can use VS Code to do even more Python than the Python environment will allow her to do.
Wow, that's insane.
Yeah, if you don't use IPython in the terminal, you're just not living right.
All right, so now we're going to check if there's only one item in the list. So yes, self dot.
I want to say head. But I don't think that's right. It's value.
No, you're good. You're good. Self dot head.
Mhm.
How do we check if there's only one thing there? So what would the value? There's something that's really close. Self dot head dot. Yes, Yvette, say it loudly.
Dot length.
Next. Self.head.next is
Oh,
none.
next.
There is a next, then there is.
If self.head.next is none,
Oh. We're just gonna take that out.
is none. There you go. Then what are we going to do?
We're
So
gonna
now we
ret-
only have one item in the list. No, we have to remove it.
Okay. So
So self.head. What are we going to set self.head to?
equal to what we were doing before, where we were like taking away. What were we doing? We were like taking away one of the nodes. Not none. Why none? Okay, now I'm
Because
why
we're
none?
deleting the head. We're removing the head. The head value is now none. There's only one item in the list, so we're removing it. We're making the list 0, right?
Okay.
So we change the head, and now we have to change the...
The tail.
Right. And now our list used to have a length, but now it doesn't.
So what do we do now? We take away the length and set it equal to 0.
Yes. Wonderful. And then we return because we need to stop it. Well, we return the removed node.
Return removed node.
Doc, now that you said something, it's driving me crazy too. So
That's how it works. It's like
I
when
was
you
pretending it was JavaScript, but
Yeah,
no.
it's like when you like
It's
when
'cause
you
it doesn't
buy
look right now.
a new car, all of a sudden there are thousands of them on the road when you didn't see them before. So, and now like you know it should be snake case, and so when you see it there, it just makes you like grit your teeth.
Oh
All right.
no.
And now we have our final thing.
Carmen, just remember it's way harder to unlearn a bad habit than it is to learn a new one.
So
Well, I didn't know until you guys just told me something.
self.head
No, I know that. I know you hadn't been that the information hadn't been shared with you yet.
equals, what are we setting it to? Our new self.head
It's equal. It's equal to. Okay, so we removed. Was that my phone? Okay. We removed a. We
Right,
checked
so we
it to
got
see
rid
if
of
it was
this.
empty. Yeah.
So now self.head, our new head is going to be
The previous node,
the
right?
next. There's no previous node. It's the next node, self.head.next. Remember, our
Okay.
previous points to none.
And when we say next, it just automatically knows what's next.
Yes.
Okay.
Yes. Then I have self.head.previous equals.
Didn't you define that earlier? You defined next and previous and node?
Yes.
Yeah.
Yes, we did. So what are we setting the previous marker to say? Where does it need to point?
Needs to point at the new node. That
No, there is no new node.
Okay, let me move this. This is blocking my.
It needs to point at, we removed a node. So it needs to point at
Nothing.
none.
Yeah, head.previous should, unless you've got a circular buffer or some kind of different data structure that's not linear. Head.previous will always
Be none.
none.
That's what I thought, but I coded it in just for safety.
Yeah, that's good.
Yeah, no, that's fine. It's fine to do that.
Okay.
But I just, it's conceptually, I wanted Carmen to get conceptually like, let me,
That it always points at none.
yeah.
Self.head
So-
always points at none. So, and now our final thing that we have to do.
So Carmen, like right here. Oh no, you took it
Oh,
away.
I'll put it back. I'll put it back.
Ah,
So here was the old head, right?
yeah, but my point is you had this arrow here. And so this arrow is always going to be, if this is your head node,
Mhm.
like Ava put right here. So
Mhm.
head dot previous, see there's nothing out here. It's the
Mhm.
void. All you have is the void. So,
So what are we trying to do? We're trying to turn the pointer in the other direction.
No.
no, you're trying to
You're severing the pointer that's
describe or
in between.
define what head dot previous is.
Mhm.
So
Okay,
head
so
dot previous will always be none.
oh, for the head. So there's always, so basically we're just saying that there's always going to be nothing in front of the head. That's what
Yes.
this is saying. Okay, I
Yep.
get it now. Okay.
And now our final thing that we have to do is change the length.
And if we're removing
Minus equals because we're decreasing it by 1. And then we return the removed node.
do I go in for this
No.
or no?
We keep it on the same line in the same scope.
Yeah, you're only going to indent when you come to either a loop, what the statements that are inside a loop, or the statements that are inside a condition. So like you've got your if statement here, so you'll always indent after that. If you had a while or a for loop, you would always indent after that. And then your function definition or declaration or whatever that's called, you'll always, like line 47, you'll always indent after the declaration of a function.
Okay.
Yep. It's
And you'll always put a blank line between functions, always.
Okay.
all right. Now we have, so now take a really close look at our add to head and our remove from head. All right. Because now we're going to add to tail and remove from tail.
Okay. Okay, so is it pretty much the same?
Yes. That's why I told you
Okay.
to take a really close look.
All right. So if we're adding to the tail though, we can still just say something like new node equals list node value. We can still say this.
Yes.
Okay. Okay. So self.tail equals new node, self.head equals new node. So it's pretty much the same.
Pretty much exactly the same.
So I could just copy this.
You could, but I want you to type it out.
Okay.
We need you need to have some practice. We're going to type it out. So the first thing we're checking for
Is if the thing is empty. So if, do we say add to, we don't say add to tail. If our new node,
if self, how do we check if our list is empty? If self.head is none. Is
oh, I keep
none.
forgetting that you can just write is.
Good. And what do we do if it's empty? No, that we're adding, we're not removing.
Oh,
We're adding. So, yep, self. We have to make a mouse.
Self.head is equal to is that right?
Yep. So we have the mouse's head. Make the rest of the mouse.
My keyboard's acting funny.
Will you remember to make a mouse, Carmen?
Yeah, I will probably. I'm actually going to go back over this stuff and write notes for myself, kind of like I did yesterday.
Good.
Because I need to figure this out.
And then what do we need to do? Now we've added to the list, so we need to add to the length.
Yeah, that's right. Self dot. Did I put 0 last time? I feel like
You did 0 last time because we removed, but we're adding, so now we make it 1.
Okay.
Very good. So our next bit, self.tail.next. So remember, so we have our little strange caterpillar.
Mhm.
So we're adding self.tail.next. So the next pointer of the tail value is going to point to
The nothing.
the new node.
Oh, I'm sorry. I keep thinking we're adding. So it's going
adding.
to equal new node.
And then
Oh.
our new node dot we have a previous pointer. Good. Equals self.tail. Now we can
So we have
reassign our tail
is equal to the next node.
the
or
new node.
node.
The new node. And then we have added the node now, and then we increase the length. So self.length
Self.length is equal to
plus
no
equals
plus equals. Plus equals
1. So self.tail has a next pointer that points to nothing. Correct?
Mm-hmm.
So what we did, my little drawing thingy is not working for me, and I'm upset. Hang on.
Mhm.
It's not working. Why are you not working? Come here, annotate. Okay. It has a next pointer. So we're making it point to our new node. Self.tail.next points at the new node.
Mhm.
Our new node's previous pointer points to the old tail.
Mhm.
Okay? Then we change the name of tail to our new node.
Okay.
Does that make sense?
Yeah, I think it does, because if we're going to add, we can only add at the tail with this. So
Yes.
when we add to the tail now has to become the new node, and the length has to increase, but then the new node also has to make sure that it, is pointing to
Points
nothing.
the old
Yeah.
tail. That's the important. New node points to the old tail.
Wait, new node points to the
New
old
node dot previous points to the old tail. And then we rename
Mhm.
the new node to be tail.
Okay.
All right, we have a little caterpillar. Here's the head, the middle, the tail.
Mhm.
And I don't know why it keeps telling me it doesn't want to annotate.
Mm.
Stop turning off my annotate screen. So we have our little caterpillar.
Mhm.
Now we have our caterpillar, it has a tail. currently points to none, right?
Mhm.
We have a new node. We want to change where the tail is pointing. Have it point to the new node.
Mhm.
Our new node is still called new node, and we want it to also point at the previous tail. Well, you can't have a tail that points to something, right?
Mhm.
So we're going to give this the new name of tail.
Okay.
Does that make sense?
Yeah.
All right. So now we're going to reverse it and remove from tail. Now this wants us to return the value of the removed node. And we are removing the tail. So first we want to save the value. Save the old value.
So what should I call it? Just remove tail. Removed
Yes.
tail. And equals what?
Self dot.
Self dot tail. Whoops, I can't see. Like, okay.
Self dot tail dot value.
Value.
Actually, there is something that we should do before that. So before we remove the tail, what's our edge case?
Oh, if the tail doesn't exist, like if it's empty.
Exactly.
So if self, should we say self dot tail?
Sure.
Or
Is none.
self dot head?
If self dot tail is none.
If self dot tail's none, then we can just say return, right?
That's right. We can just say return.
Okay.
So now we have a removed tail. So now the next thing that we need to check is if it only has one item.
Okay. So
If
self dot tail, self dot tail is equal, no, is none.
If self dot tail, well, we already checked if self dot tail was none, but self dot tail has a pointer, right?
Yeah, it does. It has a previous pointer. So if self dot tail, so if we're trying to remove, I think I'm confused. Self dot tail.
So if self dot tail dot previous is none, because we're checking that it doesn't have anything else in the list. So it would either have, the head would have a next, or the tail would have a previous.
Oh, okay. So self dot tail says none, then return.
No, not yet. We're going to remove the tail. So we're going to kill the mouse. Our mouse has a head and a tail, but we don't want it to have any of those things.
Okay.
Because we're mean people that don't like mice.
Okay, so if we're going to say it's equal to none.
Yes, we've killed the tail.
Now we just need to do the same thing for the head.
Yes. And then we had a length of 1.
Okay.
That's right. So now we have to set the length to.
Length is equal to 0.
Very good. And then we're going to return, because we're strange people and we keep mice tails.
Ew. Return.
No, we're going to return the removed tail.
Oh, okay.
We're really strange adventurers that gather mice tails. Mouse tails.
I gotcha. There we go.
So now we've checked our 2 edge cases, a no linked list and a 1 item list. Now we do the whole thing.
So now we're just going to say like self.tail
dot
no dot self.tail dot length.
No, the tail does not have a length value. Self.tail equals. I'm going to draw our little caterpillar again.
So we're removing. So self.tail is going to be equal to the previous.
Yes!
Oops. Okay, self.previous. No. Why does that look wrong?
Tail.previous. But very, very good. I am so proud of you.
I am so slow. All right, let's move on to the next.
And then
Why is it doing this to me? Okay. And then, so self.tail is equal to previous. Then we need to reassign the name of tail, right? To
self.tail.next is, because we've already got a new tail.
okay. No, why does it keep misspelling everything? Okay. Tail.next.
And what should that
is
point
going
to now? Our self.tail.next should point to
none.
yes.
No. Okay,
Yes.
that is right.
Yes. And then we have removed something.
Self.tail. So if we remove something, then we need to take away from the length.
Yes.
So self dot.
No tail. The tail does not have a length.
No.
The self has a length.
No, that's not right. Minus equal.
Minus equals.
1.
And then, like the strange adventurers we are, what do we return?
We're going to return the removed tail. Return. That doesn't look right.
It is correct.
Okay.
Did you get it?
Yes.
I was ambitious trying to get queues and stacks and doubly linked list done tonight.
Ooh, yes. Okay. Yep, I think I got it.